Welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, September 29th. I'm Mark Sponsler, and I'm your host for tonight's presentation. We'll be discussing significant wave heights, jet stream, surface level pressure, even a look at some precipitation and snow along the west coast, and then, of course, long-term outlook at the MJO and El Nino La Nina. So let's get into the details. First up, we take a look at significant wave heights for the North Pacific Ocean, and unfortunately we see a rather placid pattern. There's some seas off of the U.S. West Coast, all attributable to high pressure and wind, none of it groundswell. Again, another little area up here in the Gulf of Alaska, all aimed up towards Alaska. That's generating wind swell. Then a tropical system in the far West Pacific that is not expected to do anything for our forecast area. We'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, that is a dip in the jet going this way in the southern branch. This is the southern branch of the jet here. This is the northern branch here. And what we see is the jet is split. That is not conducive to storm development. What it does is it puts half the energy in the northern branch, half the energy in the southern branch. Either branch doesn't have enough energy to really get a good trough going or get a good support for gale development, and then you end up with a pretty weak pattern. So here we go, southern branch pushing off Japan, about normal position for this time of year, but very weak, doing nothing. The northern branch up here over Kamchatka, they finally joined forces in the western Gulf, but are ridging hard to the north. So what that does is that creates like this kind of a clockwise flow, and in the northern hemisphere, clockwise flow is symptomatic of high pressure. High pressure does nothing for generating swell. We want a trough pushing down. You get low pressure in there, a counterclockwise flow, and of course low pressure generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, creates surf. So we do have a trough. Pretty energetic one here. Unfortunately, it's all over land, over the Pacific Northwest. What it has done is created some moisture and precipitation at higher elevations. We'll get into that in a bit. What you got is low pressure here, high pressure here in the upper atmosphere. That's generating wind down at the surface and producing wind swell, but not doing anything to produce real long period swell. All right, let's put this into motion, see what's going on. We get into Monday, same sort of pattern going on. Just notice the jet is split even well inland of, what would this be? Over Russia, let's say, basically. No real change. We get into Thursday, still no change. The southern branch starts weakening. It almost looks like maybe the two jet streams are going to start consolidating, but look at this, they're way to the north, up at like 57 north, and you really want to see the jet this time of year down around 45 north. Not good. Little cutoff low off of north of Hawaii on like Saturday night, but this in general just not looking very good. What we could say though is we think a lot of this is attributable to the MJO, and we'll get into that in a minute, but the short of it is no super obvious signs for significant swell development in the North Pacific, at least looking at the upper level charts. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, and as expected, 1024 millibar high, basically filling the entire North Pacific. That is unfortunate. You also see there's your low inland, there's your fetch along the coast. It's been a couple windy days here in central and northern California. I mean, nothing unusual if it were springtime or like early summer, but it's September, almost October. You'd be expecting it to be warm and to be light winds, and we're not seeing any of that. The good news is we get into Tuesday, a little sort of gale is supposed to wrap up here in the extreme northern Gulf, 30-35 knot winds, building to 45 knots on Tuesday, 40 knots falling south into the Gulf a little bit, on the hairy edge of the north central California swell window, and then fading and kind of moving out by Thursday. Maybe a little bit of swell from that. Otherwise, cut off low here in the western Gulf, not doing much. I mean, just this is a pretty anemic pattern. It's unfortunate to say. Now here's a gale supposed to wind up over Kamchatka on Saturday night, Sunday. It too shunted off to the north, split jet stream flow, just not doing anything to help us. And here we are a week out and still nothing of any real interest. Let's go take a look at the wave model. Here we are, significant wave heights, North Pacific Ocean. We're going to focus on the northern Gulf. And there we go on Tuesday, little area, 22-foot seas, building to 25-foot seas. And holding right about 25 feet as we get into Wednesday, and then fading and pretty much gone. That should be good for small pulse of really north-angled, 14, 15-second period swell. But the suspicion is the wind machine, just like the swell, there's a swell that hit, was it Wednesday or Thursday of last week? Same deal. It was same position in the northern Gulf, and right as the swell hit, the wind starts nuking, and it just didn't do a whole lot. All right, and you can literally see seas from wind swell even into Saturday off of Northern California and Sunday, and there we are 180 hours out and nothing. So one little swell. It's October. You would think we would have had at least 2 or 3, not huge swells, but at least some, a couple feet overhead kind of stuff. We've not had that. I mean, we've not had I'll be generous and say a 15-second, 5 feet at 15 seconds, something like that. Not even that. So we are behind schedule, not unexpected. This is all sort of symptomatic of La Nina. And if you've been following the video here for a while, that's what we've been saying we think we're in, and we're seeing evidence of that now. That said, there is southern hemiswell hitting California right now from a gale that was down here under New Zealand, sort of tracked up to the northeast. Today was the peak of that swell, somewhere between yesterday and today, and it'll start fading. But there was another gale pushed under New Zealand. Here it is. This is back a week ago, last Sunday. It kind of redeveloped and lifted northeast into the southeast Pacific with 32-foot seas, and then pushed out of the California swell window. So some swell is expected into California, starting in the next 2 days or so, and to continue for a good portion of the work week, of the coming work week, if it's not buried in wind swell, but at least anything. We'll take something. Southern California certainly will probably do better. They're way more protected than up in Central and North California. Then after that, we'll just roll this out so you can see there was a gale, and it looked kind of good on like Thursday, Friday, but it fell southeast. Don't really expect anything from that. And then another tiny one, it pushed off to the east, not really doing anything. And there we are, we're up to today's date. Then we'll take a quick look up or out for the next week. The good news is, it's October, and I'm excited about southern hemiswell. That's not normal, not good. But you know what? Take whatever you can get, and here we go. Coming into supposedly Friday night, almost a week from now, 28-foot seas developing south of New Zealand, lifting kind of northeast. Another batch of fetch behind that with a tiny area of 40-foot seas. Do you believe that? That's a week out. Probably not. And the ice line way up there at like 61, 62 south. But this system, if it develops, looks pretty good. Pushing off to the northeast, you get swell. Hawaii would get swell from it. Tahiti for sure. And of course, North and South California. So we'll see. We're not holding our breath, given that it will be the first week in October when this happens. But in light of the lack of anything legitimate going on in the North Pacific, we'll just take whatever we can get and be happy for it. Looking out wind swell wise, so there is high pressure in the Gulf of Alaska, 1028 millibar high, low pressure inland. The tightening of the isobars between the high and the low creates wind, 25 knot winds off of Oregon, North California coast, generating some wind swell. That's supposed to fade as we get into Monday, and things kind of back off. Then we have our gale up in the Gulf. We talked about that. We're not going to focus on that. Wind swell. Oh, yes. We should go back and take a look at Hawaii here. Sorry. So here we are into Monday. Easterly fetch off the south end. Again, high pressure, rotates clockwise. Easterly fetch pushing towards Hawaii, building 15 knots on Monday into Tuesday. pretty decent solid fetch of trades. Another sign of La Nina when you see enhanced trades over the Hawaiian Islands and it just goes and goes and goes. That's a sign that the high pressure, the North Pacific high, is stronger than normal. That's a classic sign of La Nina. When it's weaker than normal and trades die and you start getting gales in the Gulf early season like in August and September, that's surely a sign of El Nino. We're not seeing that. We're seeing the exact opposite. We're seeing a high pressure. Trade winds not nuking, but solid in Hawaii. Trades along the U.S. West Coast this time of year doesn't bode well. It just seems like, and here comes another high, a 1032 millibar high barreling in Tuesday night. Fetch starts building along the California coast again, 15 to 20 knots. Solid fetch, 15 to 20 knots, pushing into Hawaii. Wind swell for sure. And we'll just continue. Thursday, more fetch for Hawaii, more fetch, north fetch for California. Wind machine cranking up. Cutoff low starts to belly, maybe cutting out some of the legs of the high as we get into Friday. And there were some suggestions on the models a couple days ago that something might develop up here, but that since just disappeared. Now it looks like summertime. Full on gradient, north wind off of Cape Mendocino, 25 knot thing as we get into Saturday. Trades fade for Hawaii, less or no wind swell. 30 to 35 knot winds off of Cape Mendocino on Sunday. We'll see if that materializes. And then there we are 180 hours out. There's sort of some signs of something trying to organize here in the Gulf, but nothing strong. There's no jet stream level support. And that's why we always look at the jet stream charts. The jet stream, you don't have troughs and the winds aloft aren't in a favorable configuration. You're not going to get storms and you're not going to get swell. So that's kind of where we're at. All right, since we're at it, let's go take a look at weather. So here we are, Sunday evening, rain supposedly and snow in the higher elevations in Northern California. We'll say a little dusting of snow for Tahoe as we get into Sunday night into Monday. In fact, and then it starts fading out. High pressure takes control. In fact, let's take a quick look here. This was the scene at Squaw Valley at about 9 o'clock this morning. There was not deep snow, but snow completely covering the ground from Saturday night. Same sort of deal, low pressure, a little bit of precipitation. This is at 8,000 feet. These peaks here are about 8,600, I believe. And, you get the general idea that, yes, there was some snow. Not enough to ski yet, certainly. It's September. This is actually the second time this month that there has been snow up there. And if we've been hiking up there, looking around, there was actually pockets of snow from last winter still up here. Not a lot, but just little ones here and there. So the last year's snow still has not melted. And here we go. We're already starting to get some coverage. This probably won't last. It'll warm up. It'll all melt. But it's kind of a nice little tease. Do you believe we're really going to get into some dumping situation this winter? Well, we'll be watching it. We're not holding our breath about that either. It is supposedly La Nina. Okay, so back to the precip charts. We get into Monday night. Things dry up, and we'll just roll through this. We're just looking at California. Nothing. We're into Friday, Saturday, and Sunday, and there we go, 180 hours out. So we're going to get into a little run here to last night and tonight, and then probably after that, temperatures will rise and it'll all melt off. We'll take a quick look at the Squaw dashboard. Here's the dashboard, snowfall amounts. There's our big snow for this evening. What is that? Probably about 3 inches, something like that. That's probably, seems reasonable. Here is the snow, the freezing level profile. So basically the line you're looking for is anything that's the gray is sleet. So anything that's white or above, and this is the base of squall, this is the top of squall. So here's our cold air freezing almost down to the base. And then as we get into the the Tuesday, then all of a sudden the snow level goes way up above freezing the whole way to the top for the rest of the week. Winds not so much of an issue. So you get it. We're getting a little spike of something here for the next day or so, and then it's back to normal autumn conditions. All right, let's go take a look at our long-term outlook. What's going on with the MJO and, of course, El Nino or La Nina? Well, we know where we're going with that. So first off, let's do some analysis in regard to the Baden-Julian oscillation, a periodic oscillation that traverses the Pacific on the equator from west to east. When in the active state, it's basically like a big low-pressure system. It suppresses trades, increases precipitation, transports energy into the jet stream, and helps support storm formation in fall and winter months in the along the Gulf of Alaska up into the North Dateline region. And that takes about 3 to 4 weeks for the active phase, and it just happens on the equator to traverse the entire width of the Pacific, from the West Pacific to the East Pacific. And then La Nina, same deal, but it's basically like high pressure, and it does not transport energy to the jet stream and causes the jet stream to split. All right, so we know we have a split jet stream, so let's take a look and see what we got. We have, okay, so this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. There's your equator. Dateline right there. That is New Guinea. Winds, the arrows. That's all we're looking at. From the east, solidly to a point south of Hawaii, and then over in what we call the Kelvin Wave generation area, this area, West Pacific, from 135 east to 170 west, 5 degrees north and south of the equator. When the active phase is here and you have westerly anomalies, that, again, helps feed the jet stream. Right now, winds are from the east. That does not look like the active phase of the MJO. We go look at anomalies, differences from normal for this time of year. And what we see is, yeah, there's east winds over here in the East Pacific. That's pretty normal. The arrows are almost non-existent. Same thing south of Hawaii. We get over in the Kelvin Wave generation area. No real clear direction. Basically, this is a normal pattern for right now, not indicative of either the active phase or the inactive phase. But take a note, these are 5-day average winds. So if something's changing one way or the other, it takes this chart a couple of days to pick up on it. All right, let's move on. Next up, zonal wind anomalies. That's fancy words for differences from normal for this time of year. And this is just the east-west component of the wind. That's all we care about, not the north-south, east-west. If we have stronger than normal westerly winds, that's the active phase. If we have stronger than normal easterly winds, that's the inactive phase. The reds and the yellows are what we want to see, and we want to see it in the Kelvin Wave generation area. So the Pacific starts about here, 135 east, and goes to about 90 west. But the Kelvin Wave generation area is about from here to here. So basically just follow these two tick marks up the chart. And we had westerly anomalies in the early part of September, the active phase of the MJO. It held till about the 24th of September, and we had, when that happened, we had a good run of southern hemiswell. Not the northern hemi, but at least southern hemiswell, and that was okay. But then notice, see this blue easterly anomalies, that's highly indicative, and this is the Indian Ocean over here. You see like a finger of it has reached into all in the West Pacific the whole way to the dateline. That's pretty indicative of the inactive phase of the MJO. The forecast has that going for, it was actually much worse a week ago when we looked at this. Now this chart is just suggesting maybe 3 days of that, and then easterly anomalies start retracting, and we'll say 5 days from now, the inactive phase of the MJO, at least from a wind perspective, is to die in the West Pacific. That's somewhat encouraging. And weak westerly anomalies forecast to redevelop. So maybe not such a bad pattern after all. Let's dig deeper. Let's go look at an MJO model. This is outgoing long-wave radiation, fancy words for sunlight reflectivity off the ocean surface. If you have positive anomalies, the oranges, that means a lot of sunlight bouncing off the ocean surface, and one could then assume that means high pressure and the inactive phase of the MJO, with the blues being negative anomalies, more cloud cover, and one would assume that to be the active phase of the MJO. So active phase in the Indian Ocean, inactive phase in the West Pacific, and it doesn't take a genius to look down and go for the next 2 weeks, inactive phase, slowly weakening, but still holding in the West Pacific while the active phase tries to build in the Indian Ocean. This is a statistic model, dynamic model. We look at it, it's basically saying exactly the same thing. So it's a pretty sure bet that for the next 2 weeks, we're locked down by the inactive phase of the MJO and will probably remain in a split jet stream flow. Let's dig a little deeper. Phase diagram charts, a better way of understanding the strength of the MJO and its exact position. All right, so this is this circle here, assume you're looking down on the North Pole. The MJO moves from west to east, from the Indian Ocean, over the Maritime Continent, over the West Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Okay, both the inactive and the active phase do it. They sort of follow each other, play tag team around the planet. The heavy dot is where the active phase is right now. So it is in, the far west Indian Ocean, North Africa. And the further the dot is away from the circle, the stronger it is. So we'll say a moderately strong active phase in the West Indian Ocean. The track for the next 2 weeks has it moving across the Indian Ocean and weakening. This per the statistic model. Dynamic model, if anything, has the active phase backtracking and moving over North Africa. Interesting. So a little bit of divergence between the two models here. But neither of these, so on the exact opposite side of the planet, we'll just say, boom, over here, this is where the inactive phase would be in the West Pacific. Yep, that's where it is from everything we can tell. And so you kind of get the picture. Upper level model here. So this is used for tracking potential for precipitation, but it tracks very well with the MJO. This is a statistic model, we believe. So the oranges and yellows are areas not favorable for precipitation. There's Australia and New Guinea. There's the equator right there. There's South America. You get it. So the oranges and yellow, inactive phase of the MJO, working its way across the Pacific, moving into Central America. When's that? About 18th, 24th of October? So mid-October. Okay, so we got 2 more weeks to suffer through. That's what we saw in some of the other models. Then a very weak active phase to follow. It's supposed to make its way across the Pacific into about the early part of November, and then another weak inactive phase to follow behind that. And then here's a 1 month model. All right, and this one's a little more interesting. So this is 850 millibar winds, zonal wind anomalies. So that's the east-west component of the wind again, up at about 4,700 feet. That's a good proxy for what's going on at the surface. This sort of lays out what's happening. So again, Kelvin wave generation area between these 2 tick marks going up. Here's today's forecast. So you see the blues are easterly anomalies just in the Kelvin wave generation area right here. The oranges and yellows, or the reds really, are westerly anomalies, but they're all east of the Kelvin wave generation area. So they're from the date line into Central America. That sort of smells, you can see this heavy black line here is the active phase of the MJO. This was back in August and September, and it's slowly moving out of the Pacific Ocean. Inactive phase of the MJO, the dotted contour, is building over the next 5 days. Easterly anomalies forecast for this model into about October 12th or so, making it to the date line and then slowly retrograding. So this has a slower evolution than one of those other charts we saw just a little bit ago. The interesting part about this chart is, look at this, just nuking easterly anomalies in the Indian Ocean. And this is supposed to be where the active phase is right now, and not happening at all. Things are all kind of topsy-turvy. It's a really mixed bag here, at least just looking not at the forecast, but just right now, it's like there's a huge inactive phase in the Indian Ocean, but it is the active phase, and it's bleeding over into the Pacific, but is supposed to retrograde. I don't think we've ever seen this at this time of year. If anything, it should be a pretty clear-cut, active-inactive pattern, but something strange is going on for sure, and this is not just some model anomaly. Let's go take a look at another model. So this is the 3-month model. Again, the CFS model, 850 millibar wind anomalies, and Kelvin wave generation area between these two tick marks going up. Okay, so so this is past history here. This is the forecast here. You see, here's that big ball of easterly anomalies. It's being amplified by something else. This is just not pure MJO related. But you see easterly anomalies edging into the Kelvin wave generation area. Forecast to start retrograding about mid-October, and by Halloween, out of the Kelvin wave generation area, and westerly anomalies start rebuilding, and we sort of fall into a more normal pattern once we get through October into November and December. Let's overlay the MJO. Okay, now here's 1, 2, 3, a 4 contour inactive phase of the MJO. We haven't seen this for quite a while. This is a pretty strong inactive phase of the MJO, indeed. Anyway, so it's going to lock us down till Halloween. Then the active phase, 1, 2, 3, 4, a 4 contour active phase develops, feeding westerly anomalies. This is a big red X here for swell development. So we'll say from Halloween through Thanksgiving. So that wouldn't be too bad. And then after that, a kind of a weak pattern, neither active nor inactive, very weak inactive again. All right, so let's overlay the low-pass filter. So here's where things get interesting. So supposedly, this solid contour is like a low-pressure bias, if you want to call it that, and it's been over the date line, and it's supposed to rebuild. We've been talking about this for weeks now on these videos, and it's still hanging. In fact, we're supposed to move to 2 contours as we get into next week, and then possibly 3 contours as we get into December. This keeps pushing out. I mean, this almost smells. So this is what you'd expect if you saw El Nino developing. We don't believe that for a second. And what's even more interesting, again, this dotted black contour is a high-pressure bias building in the Indian Ocean. And you're going, really? Is that really possible? Are we like going back into El Nino? I mean, so low pressure in the Pacific, high pressure in the Indian Ocean. If anything, it probably should be the other way around. But we'll see. This model has been just rock solid on this, and even the ocean, when we get into the ocean temperature data, you'll just see it's not even, there's some sort of disconnect, maybe, just maybe, but things are changing a little bit. So keep this in your mind as we move forward here. All right, so let's go take a look down in the ocean, okay? We've looked at the atmosphere kind of stuff, but the ocean has its mind, and it does what it wants to do. The ocean, the air above it will blow and try to move things around, but the ocean has a lot more mass. It takes a lot longer for it to change. So what's going on? Well, we see 30 degrees centigrade. What's that? 1.8, say 30 times 1.8, whatever that is. It comes out to be like 80 degree water. This is subsurface. So this is the surface here. This is down 100, 200, 300 meters. West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys strung the whole way across the Pacific, just from 2 north to 2 degrees south, so over a very thin line over the equator. Anyway, connect all the data, you get, and use some modeling software, connect the dots, and you get a profile of subsurface water temperatures. So we see warm water here. It's actually holding steady. I mean, this actually shrunk significantly 6 weeks ago or so, starting to rebuild. The 29-degree isotherm has made some eastward progress to 159 west. The 28-degree isotherm was locked solid at 160. Now it's about 157, 156 west. 24-degree isotherm holding at about 124 west. The point being, it appears there is some warm water gently starting to move off to the east. It had backtracked significantly a month or so ago, and now it seems to be trying to ease to the east a little bit. This sort of supports what the previous model was saying about this building low pressure bias in this area, because when you get that, you get more westerly winds. The westerly winds start making Kelvin waves, or at least start forcing warm water to the east, and the more warm water you have in the east, the closer to El Nino you are, and the closer to El Nino you are, the closer you are to having a a strong jet stream and better hope for storm development and precipitation. All right, moving to anomalies. So here's where things even get more interesting, okay? This is differences from normal for this time of year, water temperatures, all right? So we have what almost looks like a Kelvin wave. We've had westerly winds here blowing. They take warm water in the West Pacific, push it to depth. It's a Kelvin wave, and you'll see in another chart, we've had a series of Kelvin waves, but they just stalled. They've hit this brick wall, and there's been cold water over here, and just, they can't go anywhere. They're stationary Kelvin waves. Is that what we're calling them? Well, an interesting thing happened last week. There was cold water, like 4 degrees below normal. Now, a little bit at a time, it's eroding. It's only 2 degrees below normal. It's moving off to the east, and you see warm water passing above it and below it and cutting it off. I mean, there was literally, where's 150 west? There it is, right there. So there was literally a brick wall right here 2 weeks ago. It was all warm on this side, all cold on this side. Now we see some sense that the cold water has given up the ghost a little bit, and we're getting incursions of warm water. Now the question is this just a temporary thing, or is it a sign of a trend to come? And this is the real million-dollar question for this winter. The GODAS sea surface temperature, just basically a different model, and it tends to run behind. This is September 25th. The other one's like updating every day. It still shows that big ball of cool water, but it shows the cutoff point at 140 west, where it was at 150, and you get the sense 1, 2, 3, 4, 1, 2, 3, 4, 2 to 3 degrees above normal. So this one almost suggests that the warm water is warmer than the cool water. You know, I think this is just typically about a week behind reality. So keep that in mind. Let's move on. Sea level anomalies. Just another way to look at sea surface temperature data, but it's done via satellite. And the subsurface temperatures. So how do you read temperatures below the ocean surface with a satellite? Well, you can't, okay? But you can infer it. And the way you infer it is you measure the height of the ocean surface, okay? And we're talking centimeters, small amounts, okay? That's a centimeter, basically, okay? So what from the Jason 2, Jason 3 satellite, you strip out all the waves, you strip out the wind waves, you strip out the tides, and then you just see, is the ocean higher or lower than normal for this time of year? What you see is 5 to, and we're only talking like 5 degrees north and south of the equator, but you see this big bump here of higher than normal sea heights right here. What that means is warm water at depth, it expands, creates a bump on the ocean surface, literally. So this suggests, yes, that Kelvin wave is in fact there under the date line. And over to the east, we have cool water, minus 5 centimeters. So cool water contracts, creates a divot on the ocean surface, and we're able to measure that. And it's a triangle, though. It looks like there's cool water all along here, and and east trades blow over here, trying to make headway into this Kelvin wave. But if anything, the Kelvin wave, you see that? Like the tip of a spear? And a new pocket right here, a couple little pockets here, suggests that warm water is, in fact, making a incursion to the east. So this is kind of good news. It's kind of late in the year, but we'll take any warm water we can get. That's all moves us in the right direction. Okay, upper ocean heat anomalies. We'll slide up there. There you go. Okay, so this is the West Pacific here. This is the East Pacific here. The reds, oranges are warm temperatures. The blues, cooler than normal temperatures. So we're going back. We're looking at Kelvin waves, literally looking at the migration of Kelvin waves in the past, October 2018. Here was a good Kelvin wave. Last year we were in kind of a weak El Nino thing, westerly anomalies, taking warm water in the West Pacific, pushing it off to the east. This is like Kelvin wave number 3. Kelvin wave number 4 in January, February of this year. And then here are these stationary Kelvin waves that we talked about. The interesting part, they didn't make it very far. They were here, and there was cool water over here in the West Pacific too. So even no matter how much how much westerly winds you get, you try to get a Kelvin wave, but if you don't have enough warm water here, it's kind of hard to develop a Kelvin wave. Anyway, the point being, we had 2 of these, just like, very anemic Kelvin waves. And here we are in September. We had a westerly wind burst associated with the active phase of the MJO. Look at this. It's actually making some progress to, what? 140 west, pushing towards 130. So the question is, how far east will this Kelvin wave make it? I don't think that it's going to do any better than maybe this one here back in June. But we'll see. It's part of a game we're watching. The point is, are we in La Nina? Well, it kind of looks like we were, and we'll get into that in a minute when we look at surface temperatures. But now it looks like whatever La Nina we're trying to go in, at least for the moment, I mean, literally, this is not a trend. This is all this has been happening just in the past week. Sort of looks like the La Nina pattern at least is like losing it for a little bit. But we're in the inactive phase of the MJO. If anything, it should be strengthening it. But instead, it seems to be losing some of its gusto, at least in the ocean. And you can see that here too. Upper ocean heat anomalies, basically the same chart above, but this is just total warm water between the date line and 100 west. So say the central and east Pacific. Go back in October, large volume of warm water. And this is like a Kelvin wave. Inactive phase or upwelling phase of the Kelvin wave cycle. Another Kelvin wave. Then you can see it's just this steady downward trend. And then we sort of fell into a hole here. This is when we got that building cool water pull subsurface in the East Pacific. Now we're on the way up. As I say, yeah, you can be up and then you go down, up and down. So is this up really going up, or is it just a little blip and we're going to go back into this hole, or maybe even a worse hole? Hard to say. And we think a lot of this is all governed by, this would be active phase, inactive phase, active phase, inactive phase. You get it. We're in the inactive phase. Right here, we're in the inactive phase of the Kelvin wave cycle. It started about mid-September, but we're getting warm water developing. That's the head scratcher. But anyway, let's move on. All right, sea surface temperature anomalies. All right, differences from normal for this time of year. And as expected, here is our cool pool off of Peru and Chile. There's a little, and actually this up here, this area was much warmer. It has backed off. So this all smells of some developing La Nina pattern. Cool water starting to work its way to the west. But instead of doing that, I mean, cool water was like almost off the chart here a week ago, 2 weeks ago. All of a sudden, warming. And pockets of warming building to almost 120 west. That's interesting. Let's not take that to the bank yet, but let's move on. Sea surface temperature trend. Okay? So, a little bit of warming here, and just on the equator. That's all we're interested in here. Along the Galapagos. Little pockets of warming, and yeah, there is a pocket of cooling here and there. But last week, I think we had broad warming over here. We've lost a little ground, but not horribly so. So, for the past week, I'd say it's been a wash, at least according to this chart. But looking at the data, clearly there is a warming pattern going on, we'll say, in the Central Pacific. And then sea surface temperature anomalies. I mean, so you probably don't remember, but yes, here's our cool pool. Here's our cool water moving on the equator to the west. But it had reached as far as almost the dateline 2 weeks ago, then backtracked a little. And then you look at this and you don't have continuous cooling until you get to about 137 west, something like that. This is the last little pocket here, and that looks like it's filling in. So certainly we're in a pulse, a favorable pulse. It does not look like La Nina for the moment. So the official El Nino monitoring region is from 120 west. So all this over here, this is in what they call the Nino 1.2 region. It's the Nino 3.4 from 120 west to 170 west, 5 degrees north and south of the equator. You look at that, well, yeah, there's cool water, but there's also pockets of warm water. The whole western half of that is warmer than normal water. And we're disregarding all this here because you'd be shocked at how very specific it is about where the warm water is, and it has to be on the equator, it has to be in certain areas to really have an effect on the jet stream. So if the cool water is retreating, and if it lasts for a couple of months, then one would say maybe the jet stream is going to wake up and this is just a temporary blip. And the point being, this one model has been hinting at that happening for quite a while now, and we've completely blown it off and just said that it isn't going to happen. The model is out to lunch. We're moving towards La Nina. All of a sudden, we're getting just little hints. It's not real. It doesn't, I don't think it's going to happen, but maybe. So let's dig a little deeper. But first up, sea surface temperature anomalies. So this is in the Nino 1.2 region. This area over there by Peru and Chile and the Galapagos. Latest data. Look at that. We've made a rebound. We talked these are 1 week increments here. We've gone from minus 1.7 degrees or so to down to today's reading 0.406. So a significant improvement in the Nino 1.2 region. But even more interesting is in the Nino 3.4 region, the official El Nino monitoring region. We're in a big old hole down. So the scales are different on these charts. 0.6 of a degree back 2 weeks ago. We are effectively at normal today at 0.14. And you saw that on the chart. It was like half cool, half warm in the Nino 3.4 region. So that's good enough. Get you to 0. We'll take it. Can we hold here? That is the $1 million question. Or even just get a little bit of positive, but not fall back into a hole like this. Don't know. Way too early to know, but maybe. So what's going on in the atmosphere that might influence this? One way of looking is the Southern Oscillation Index. It's the only thing we really have data for right now. Difference in pressure between Darwin, Australia, and Tahiti. When you have lower pressure in Tahiti and higher pressure over Darwin, then that is, we'll say, that is like El Nino if it lasts for 90 days or, a long period of time. Short variations, like on the scale of 2 to 3 weeks, are the MJO. So basically, El Nino is like a long-running active phase of the MJO. Anyway, today's contribution, 0.95, basically dead neutral, neither active nor inactive. That's kind of a good news. The interesting part, so we've been looking at the models. They're all saying we're in the inactive phase of the MJO, but you go all the way through September. Look at this. We were negative numbers. This was strong, active phase of the MJO. Negative, negative, negative. Now we're at neutral. But you'd think if we're in a strong, active phase, this would start going really positive. Well, we're not there yet. Okay? The 30-day average, minus 13.39. That's, that's, say, an active phase. The 90-day average, this is your El Nino indicator. If it was down at minus 12 or 15, then you'd say El Nino. We're at minus 7.42. So still we're neutral biased towards El Nino. Now, the thing is, maybe what's going on, remember we see this warm water incursion that we were talking about on the equator? Maybe that's the result of this active phase of the MJO and westerly anomalies and warm water pushing off. And as the inactive phase of the MJO builds over the next 2 to 3 weeks, then we're going to lose ground and cool water will start upwelling again in the east, and we'll be right back where we were 2 weeks ago. So that's probably the likely scenario. But let's go take a look long term at what at least one model says. This is the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. And no, it hasn't updated, at least with actuals. The last really good valid data was about, midway through September? So that's about right. And it showed temperatures rising, which they are doing right now. But it says by October 1st we're supposed to be half a degree above normal. That ain't going to happen. We'll be lucky to just be a little bit above normal because October 1st is, a day away? Anyway, maybe a week away. Anyway, the model has long-term, so this was saying that we were going to be like hanging about a half degree above normal. But now, during this week, it sort of settled down and said, we're probably just going to eke out a normal water temperature pattern. Not El Nino, but not La Nina either, and holding through the entirety of the winter. And you know what? If we got that, I'd be thankful. I'd be happy. It's better than La Nina. It's not El Nino, but neutral is not horrible. Sometimes you can get, during the active phase of the MJO, you can get good spurts of swell activity. You can get good, as the MJO moves south of California, you can get good snow events over the Pacific Northwest. So we'll see. That's what the model says. This is probably closer to reality than the fantasy that it was selling weeks ago. I think part of the key here is we need to watch the water temperatures in the East Pacific and see what happens over the next 2 to 3 weeks. I don't think we're going to get this spike, but if we get just a little spike, that might be okay. And that might be enough to sort of hold off the momentum and like keeping us from falling into a La Nina hole. We just don't know. It's too early. We've been saying La Nina or some weak version of La Nina. Still suspect that's going to be the case, but there's a glimmer of hope at the moment. So to wrap things up, southern hemiswell in the water. It's hitting right now. Another one behind that. For the North Pacific, yeah, a little gale forecast for the northern Gulf. A little bit of swell from that, but probably buried in wind swell. So wind swell is the name of the game, and it typically should not be this time of year. And that tends to make us think La Nina. The thing that's not making us think La Nina, at least for the moment, is the incursion of warm water to the east on the equator. We think that probably is a temporary scenario, but maybe it's temporary and strong enough, though, to prevent us from falling into a full-bore La Nina, and we'll just sort of sit neutral for the winter. And that wouldn't be horrible. And if we're neutral, maybe we'll get just a normal rainfall pattern, or even sometimes when you go from this El Nino to La Nina sort of pattern, you get colder than normal air in California, which we're kind of having right now, and you get just, not above normal precipitation, but because of the cold air, whatever precipitation you get creates more snow than normal, whatever, just a lot more volume, and you end up with a pretty decent ski season from that. So maybe that's where we're going to go. Way too early to know for sure, but certainly we're not in El Nino. So that's it for this week. We're going to do this again next week. Same time, same channel. Be sure to hit the like button down there on the lower right if you like the video. Subscribe if you haven't subscribed. Hit the bell there, and you'll get notified every time we do an update. Or, of course, on stormsurf.com. That's our site. All the data can be found there. And we also post a link to these videos on the site. So thanks for watching. We'll see you again next week.